All right, let's find the derivative of some inverse trig functions, like y equals the inverse cosine of x. I'm going to split this up into two parts, a lot like it's split up on this review sheet, where in part A, I want you to find the derivative in terms of y. Now, the thing about y equals the inverse cosine of x is that that means that the cosine of y is equal to x. So we can solve this or find this derivative implicitly by taking the differential of cosine of y, which would be negative sine y dy, and the differential of x is dx. Now it's just rearranging things. I want to have dy dx, so I'll divide by dx. And I want that to be alone, so I'll divide also by the sine of y, by negative sine of y. And what that will leave us with is dy dx is equal to 1 over negative sine of y. That's all I want for part A. That's the derivative in terms of y. In part B, I want you to take the next step and find the derivative in terms of x. And that's where we're going to need the triangle. If you go back to our very first step where we have cosine of y is equal to x, the angle would be y. So I'm going to take that y and put it in one of the angles. Since it's the cosine of y that's equal to x, remember from SOHCAHTOA that cosine is adjacent over hypotenuse. And that will mean that the other side that we're left with a little quick Pythagorean theorem, will leave us with hypotenuse squared minus side squared. So 1 minus x squared. Now we can refer to this triangle when we're trying to find out that derivative, dy dx. We know that it is negative 1 over the sine of y. And looking at our triangle, sine is opposite over hypotenuse. So square root of 1 minus x squared. And that's it. So let's do it again with y equals the inverse sine of 3x squared. First, find the derivative in terms of y and x. So I'll rewrite this as the sine of y is equal to 3x squared. Then we can take the differential. Derivative of sine is cosine, so the differential will be cosine y dy. And on the right-hand side, that would be 6x dx. And we'll get it in order. I want to have dy dx, so I'll divide both sides by dx. And I want that to be alone, so I'll divide by cosine y. Then our answer is that dy dx is 6x over cosine y. That's done. Right? We found the derivative in terms of y and x. Now let me move my B down here so we can get better access to my triangle. We want to use this triangle to help us find the derivative strictly in terms of x. Now remember, going back to our very first line right here, sine of y is 3x squared. That means that the angle is y. And the sine is 3x squared. Sine is opposite over hypotenuse. So quick Pythagorean theorem here. We'll leave this side being the square root of hypotenuse squared minus side squared. Right. Then we can go back and rewrite our answer. Dy dx is going to be 6x over the cosine. And cosine is adjacent over hypotenuse. So our adjacent is the square root of 1 minus 3x squared is 9x to the 4th over 1. So that is our derivative strictly in terms of x. All right, finally, let's do it with y equals arctangent of 4x. So that will mean that the tangent of y is 4x. And we can start taking differentials. Derivative of tangent is secant squared. So secant squared y dy. And over here we'll have 4 dx. Divide both sides. First by dx because I want to have dy dx. Then by the secant squared of y. To get them to cancel on this side. Now we're looking at dy dx is 4 over the secant squared of y. and that is our derivative in terms of y. In order to turn it into the derivative in terms of x, we go back to that original line. Tangent of y is 4x. That means that y is the angle. And the tangent is 4x. Well, tangent is opposite over adjacent. So, quickly, the Pythagorean Theorem. Find the hypotenuse. We'll have the square root of the side squared plus the other side squared. So, dy dx is going to be 4 over the secant squared. Well, the secant, we have to remember, is the reciprocal of cosine. Cosine was opposite over hypotenuse, so now we're going to go hypotenuse over adjacent. And that'll just be the square root of 1 minus plus 16x squared. And when we square that, remember we're not squaring this 4, but when we square that square root, we'll have 1 plus 16x squared. And we're finished.